Hi, Algebra 2. We are going into our second day of polynomials. So again, we were talking about how polynomials sort of represent this increasing and decreasing height, sort of like a roller coaster. Works very well. Good comparison. Go ahead and label your notes though for day 2. And we are going to be finding the real and imaginary roots. And we've talked about this word roots several times. And we've talked about it as roots, x-intercepts, zeros, solutions when f of x equals 0. Those all mean the same thing. There's going to be a slight difference though when we talk about roots today, and you'll see why the word roots is a different word than x-intercepts or zeros. So our first example, I'm going to use my calculator online, but if you guys have a calculator, go ahead and pause and grab your calculator because you guys will want to try this. You can always find total number of roots. So the total number of roots that a function has is equal to the degree of the function. So the total number of roots equals the degree of the function. And see if I can fit the word degree in here. So when I'm looking at example 1, if you guys notice, the highest exponent is 3. That's called the degree of the function. It's not only the degree though, it is also the total number of roots that this function will have, okay? And I'm going to underline the word total. Some of them you're going to be able to see and some of them you won't because some of them are imaginary, some of them are real. But the total number is 3, so it matches the highest degree. In number 2, our degree is going to be 4, so the total number of roots is also going to be 4. So now we need to figure out if we actually can see those total roots. So if we look down here in number 1, the graph of 2x cubed minus 6x squared plus 5, it's graphed right here for us. If you guys notice, you'll see 3 places where there are solutions or x-intercepts or zeros. I see 3 right here. So I'm going to say I have a total number of zeros, 3. I was supposed to have a total number of roots that was 3, and here I have 3. So those all match. I have 3 roots, and they're real because I can see them. If you guys come over to number 2, though, I'm supposed to have 4 roots. But when you guys look at the picture, I only have 2 zeros that actually cross. So if I'm supposed to have a total of 4, I only see 2, then what are the other 2? Where are they? So this is when we're talking about imaginary versus real. For number 1, we had a total of 3 roots. There were 3 real ones because I could see them. They were right there. Okay, I could see all of them. So there were no non-real roots. There were no imaginary roots. Non-real, also imaginary. Okay. But in the second example, it's a little different. In the second example, I was supposed to have 4 total roots. I only see 2 of them, so 2 of them are real. Well, that means that 2 of them are imaginary. So they're up here somewhere, but they don't actually cross. They're imaginary roots. So I can see 2 of them. I'm supposed to have 4 total, so that means the other 2 are going to be imaginary. Okay? So that is how I can decide whether a function has real or imaginary roots, or how many total roots it's supposed to have. I can do it just based on the picture, okay? So pause the video here if you'd like to look at that one more time. Here I'm going to grab my calculator and I'm actually going to graph both of these. I want to know what the total number of roots is, what the real roots are, and then what the non-real roots are. So I can already look at both of these and I can tell the total because, again, the total is supposed to be the same as the degree. So my total, let me erase that. There we go. My total for this first one should be 5. Okay, so now I'm going to try to find real roots and I'm going to try to find imaginary roots. For number 2, again, I know my total is going to match my degree. So I should have a total of 3 roots. But my job is to look at the picture, graph it, and see which ones are real and which ones are imaginary. So I'm going to go ahead and grab my calculator. I want This first equation is now typed in to y equals, and we are going to make sure that our zoom is on standard, so number 6, and we'll graph it. Okay, we've talked about the behavior of a quintic. So it does sort of represent a cubic here, and it is an even degree. So, not even, it's a positive. So it's going from down, negative infinity, to positive infinity when you look at it from left to right. But it only looks like it's crossing once. So that means I have one real root, okay? One real root. So let's go back to our notes. I have one real one, which means that 4 of them are imaginary. If I can only see one of them, that means 4 of them are imaginary. 1 real 0, 4 are imaginary. Let's go ahead and graph the second one. All right, so the second one is in, and when we go to graph, this one's a cubic. Haha! So it went up, it increased, it decreased, way down below our graph, and then it increased again. The total I'm allowed to have with a cubic, because remember my degree is 3 here, so that means the total roots I'm allowed to have are 3. And look at this, I see all 3 of them. So that means all 3 of them are real, and I do not have any imaginary. Okay, so if I'm looking at a picture or a graph of a function, I can tell immediately how many are real and how many are imaginary, because I know what my total is, and I know which ones I can see, and the ones I can't see would be the leftovers. Okay, those are my imaginaries. Now, that was all just by graphing, so I could do all that in my calculator. Sometimes, though, you're going to have to obviously solve it and figure out the roots, not by graphing. So we're going to have to bring in a little bit of what we did before, which is factoring. And this was one of our weak points from the last few units, so I'm glad that we are reviewing factoring. Just as a review, let's go over how to factor our trinomial here, x squared minus 5x plus 6, when it's set equal to 0. We started by setting up our 2 binomials, because we know a trinomial can factor into 2 binomials. When we reverse FOIL, we're thinking of what 2 numbers multiply, or what 2 terms multiply to make x squared. So usually we'll put our x and our x as the first term in each binomial. Then we need 2 numbers to multiply to make 6 and add up to make this negative 5 here. So we're going to use, let's say, 2 and 3. Those will multiply to make 6, but I want them to add to make negative 5, so we're going to make them both negative. Okay? Since I have 2 factors, these 2 factors are multiplying to make 0. That means one of them must equal 0. So we're going to take both x minus 3 and set it equal to 0, and we're also going to take x minus 2 and set it equal to 0. All right? So we add 3. We wind up getting x is equal to 3, and we solve the other problem, add 2 to both sides, and we get x is equal to 2. So we wind up having 2 solutions to this equation. That means that if x is 3, we get 0 as our y value, and if x is 2, we get 0 as our y value. All right? This completely will go right in with finding roots, because you're finding zeros here. You're finding when f of x is equal to 0, which means you're finding when this graph crosses the x-axis. So that means I know that at 2 and at 3, right here and right here, this graph is going to cross the x-axis. Okay, this isn't a very neat picture of it, but that's basically what's happening. We have a parabola and it's crossing, and I found both of my roots right there. So we're going to find a few more of our roots by factoring. And this is a good review of factoring for us as well. Let's just focus one at a time. So this first one here, it is a cubic. And what I notice immediately is that I can factor out a GCF. So I'm going to go ahead and do my GCF first. And my GCF I notice because I have an x in all 3 terms. So I'm going to take out the GCF, and I'm going to be left with x squared plus x, and then minus 2. Since my GCF is x, I'm going to leave it alone. It's going to stay outside the parentheses. I factored it out, and I'm going to try to factor the trinomial that I have into two binomials. Okay? Again, first times first makes first. So x times x is going to make the x squared. And then I need two numbers to multiply to make this -2 and add to make 1 for the x, the middle term. So two numbers that multiply to make 2. Okay, so 1 and 2 work. And then how can I add them up to get a +1? I'll have to make a -1 and a +2. So 2 times -1 makes -2. And then 2 plus a -1 makes 1 for the middle term. So now I have 3 factors. And that was by reverse FOIL there. Okay? I have 3 factors, and every single factor I need to set equal to 0. So since this x is here, it's not just a number, I'm going to have to set x equal to 0. And I'm going to set x plus 2 equal to 0. And I'm also going to set x minus 1 equal to 0. So I'm just setting all 3 factors equal to 0. This one is already completed. X equals 0. I can't do anything else to it. For this one, I'm going to subtract 2 from both sides. So I'm going to get x equals -2. And then I'm also going to add 1 to both sides here. So I'm going to get x equals 1. If you notice, when you look back at the parentheses, looking at our factors, if it's just x, then I get 0. If it's x plus a number, my answer winds up being minus. So it's opposite of what's in the parentheses. So x plus 2, I wind up getting -2 as a root. And then I have x minus 1 as a factor, and I get +1 as a root. So it's always opposite the number that's in the parentheses. Let me just grab my calculator, because if you guys look back, I'm supposed to have 3 roots and I have 3 answers. So that means I have 3 real, goodbye. Okay, that means I have 3 real roots as part of my finding my total roots for my cubic here, okay? 3 real roots. I don't have any imaginary ones because I did not find any imaginary ones. They were all real. All right. Let me pause this for a moment. Okay, so just to show you, if you guys take this equation and we graph it, the graph is showing us that we have roots at -2, 0, and 1. If you look at your picture, -2, 0, and 1, they match. All right, so then you know you did it correctly. Let's go ahead and try another one together. For this one, I have to make sure that my function is set equal to 0. So I'm going to move this 5 over to the other side. All right, so that means when I'm starting, I'll draw a little line here so I have some space. I've got x cubed plus 5x squared and minus x and minus 5. So everything is on one side and we have it set equal to 0. All right. Now this was one type of problem that I had mentioned to a few of you that we were going to do later in the year, and this is called factoring by grouping. If we have 4 terms, we can't just factor 4 all at once, so we're just going to split it into 2. And if you notice, if I put a parenthesis here and I have a negative on the outside, it's going to wind up changing the numbers that are on the inside. So if I put my negative in the middle, this is going to make minus x, which is what I wanted. But I really want a -5, and right now negative times negative makes positive. So I'm going to have to change this to a +5 when I add that parentheses here. So I've grouped. Now I'm just going to take out a GCF from each group. So my greatest common factor between these two terms is x squared. And I'm going to have an x left over and +5. I do not have a greatest common factor in the second set, so I'm just going to leave it as x plus 5. But what you guys will notice is that the two binomials match. So that now becomes my GCF, which means that I can pull out x plus 5. And what I will have left is x squared minus 1. Okay? So now we are going to set both of these binomials equal to 0 and solve. Go ahead and pause here to try it. So in example number 2, we had 3 roots and we got 3 separate answers.